Hello, everyone. Welcome to this episode of the Coding Cube. My name is Jordan Bell, and today we have Ed Freitas joining us. Among other things, Ed is an ebook author that already has several published works under his name. Today, Ed would like to speak about an app for his upcoming release, Angular Dart Succinctly. So, Ed, what's new with this app that's been developed?
Hi, well, thank you very much for the invitation. And this is basically a small application that shows how to track important documents that have an expiration date, such as passports, driver's license, and any other document that has a date that expires. So it's really a small example, and just to highlight practicality and beauty of Angular Dart, so we can have a look at it. All right, so here we are at the application. As you can see, it's basically a list of documents, and this list can either grow or shrink depending on the items that we want to keep. So let's say we want to add a new document, right? So we say here, this is going to be a driver's license, okay? And it will expire in 2029 and will be in January and on the 31st. So we can also choose to set some alerts. And these are actually symbolic. They don't actually do anything because you would need to have some backend code running on the server, on the web server, to actually send you the alert. So this is just symbolic. And it's a way that you can continue to expand the application after you read the book. So for the moment, let's just set an alert that 12 months before it expires, you will get a notification, and also 6 months before. So we can save that. Forgot the S here. And let's save that. And there we can see the document. It's been added to the list with an expiration date of the 31st of January 2029. We can also choose to edit, because let's say we made a mistake. It's not January, but it's February. And then what happens is the number of days will change, because we don't longer have 31 days in Feb. We only have 28. So this list is dynamic based on the month. If it would be November, we would have 30 days and not 31 or 28. So it's a very practical way to keep track of documents. And as you can see, it's using Google's material design, which is a great CSS framework for styling applications. Another interesting thing about the app is that, for example, documents that have expired will have a different color. And if we also change the year, let's say we set this to 2021 because it's closer to the expiration, you can see that the number of days also is updated accordingly. So again, very simple. It's just basically a document list, nothing else. We can choose to either edit documents or add new ones. So let's say we want to delete the one we just added, we can do that, and it's off the list. Now, this list, this is running locally, as we can see here, but the actual information is stored on Firebase, which is a Google service. So it's like a NoSQL document database, which stores JSON objects, and it's very practical and very easy to integrate. So let's switch over to the code so we can have a better idea of what this is and how it works. We have our starting point is this public specification file, and this basically tells us in AngularDart what components our application will be using. So in this case, we have the dependencies, which is AngularDart itself, Angular Forms, Firebase, and we're not using Angular components, so that's been commented out. We also have some development dependencies, such as Angular test, build runner, build test, and some testers like and linters like pedantic and test. So nothing too extraordinary there. We also define here the SDK version of Dart. that we will be using, and obviously the name of the application and a description. We can also set some other information like a version number and home page. So this is all customizable, and obviously it depends on basically the needs of what components your application will require. A great thing about doing this in Visual Studio Code is that if you click on this button, you will basically get all the packages downloaded and installed for you. So it's really a great feature from VS Code. With these components defined, our next point is to look at the index.html file, which, as you can see, is basically HTML5. Nothing too extraordinary here. Links to Font Awesome, as we can see in these two lines. We also have a link to Bootstrap, so just simply the minified CSS of Bootstrap. And we also have material design for Bootstrap, also referenced from a CDN, which is Cloudflare. We also have our own little custom styles for the application. You'll see shortly, it's not really much. And a reference to the Firebase SDK, as you can see here. And our app's main entry point for code, which is main.dart. So main.dart simply imports AngularDart and the app's main component, which is that one there, which we'll have a look shortly. And it runs the application by executing this main function. With regards to styles that are specific to the application, we just have a couple of things here. Imports to specific Font Awesome fonts, and just some padding on the body, and again, specifying the font family we're using. So nothing too difficult there. So let's have a look at main.dart. Sorry, we did that already. Let's have a look at our components. So the application is structured into components. The main component is my app, which is basically the whole application. And when the application starts, it will display this loading message. So my app is actually included here in app component. So if we look at app component, we have the my app component, which references another component called DE-base. And DE-base is here in this folder, which contains two files, a Dart file and an HTML file. Let's look at the Dart code for this component, for app component. And you can see that the selector is my app, which is the one we reference in the index.html. And the template file is appcomponent.html. We also include some directives, which is doc expire base, which is this DE base component. And we say that our style is appcomponent.css, which if we have a look, it's really empty. It doesn't contain any specific styling for that component. So essentially the application is pretty much structured like a regular Angular application in two folders, and each folder will be a component. The difference is that instead of using TypeScript as a language, we basically use Dart as our programming language. So let's look at our HTML file here. We reference DE-base, and DE-base is actually this one here. So let's have a look. So this would be the main screen. So if we switch back to the browser, this would be what you see in that code. So if we go back to the code, that's what you just seen there. So basically, the screen is divided into several divs. such as the title of the application, right, which we can see there. And then we have a body which contains a document, so a list of documents. We can see here the document name, the expiry column, and remaining days. So, which is basically that there, and that there. So those three columns are defined here. And just like you would do using regular Angular, you can basically loop through your list of documents or items using an ng4 directive. So as you can see, this is exactly the same as Angular. Nothing different, the same syntax for displaying variables and objects, all embedded within the HTML. So that's exactly the same. If we continue to look at the HTML, we have also the button for the new document. So if we have a look at that, which is this one here. And then we have this deform component. So this is hidden. So you don't actually see that in the main component. And this is a secondary component, which we'll have a look shortly. And it basically is this. So when we click on the new document button, we get the second component, which is that deform component. And that component has several events attached to it, such as update document, insert document, cancel new, or remove document, which, as we can see here, is linked to actions such as save and cancel. When it's a new document, the delete button doesn't appear because we have nothing to delete. But if it's an existing document, you can see here that the delete button does show up because there is a document that we can delete. So this is essentially what the eForm does. We'll have a look at that shortly. If we look at the code behind for the main component, which is the base, we can see a whole bunch of stuff here happening. We reference our model, which is basically a representation of the JSON database for the application to use and consume. And we also have a doc service, which is responsible for doing the communication with Firebase. Nothing too fancy here. We simply have handlers for the things that happen in the events. So basically to load the data, for example, if the name of the document is too long, we call this ellipsify function, which essentially makes the description of the document a bit shorter, because if you see here, this description is quite long. It would not fit in the window. So ellipsify basically makes it shorter. It adds these three ellipsis buttons to the end of the description, making it a bit shorter, and therefore it could be displayed in any resolution. And obviously there's more logic to this. So we have functions to edit a document, to remove a document, cancel when a new document is being created. Here's ellipsify. So all the logic for this component to work is basically written in this DE-based components. As you can see again, the programming language is Dart. So there are some similarities with TypeScript. For example, this component annotation is very similar to what you would get with Angular and using TypeScript. The differences are the syntax of the language. For instance, this is specifically for Dart, whereas with TypeScript, it would have a different syntax. So once you get the hang of it, it's not really difficult at all. It's very easy to take TypeScript and apply the same logic in Dart. Let's have a look at the Deform component, which is our second screen. And as you can see here, it's basically placeholders for all the fields our document has, like the year, the month, right? So let's switch over to, so you can follow me. So there we go, year, month, day. And here we have day as well. And also the alerts. So here we have the input for the alert and its label, which would be that one there, this one here, and the same for the other ones. So the way this works is just like it would in Angular. We have regular two-way data binding using ng model, and obviously we give this an ID for each one, so each one has its own unique ID. So nothing different that what you would do in Angular, just again that the code behind is all in Dart and not in TypeScript. So again, using directives like ngIf, click events, and obviously attaching those to code behind functions. So if we look at the code behind, again, we import our model, which again is nothing more than a representation of the data that we store in Firebase. We have the regular Angular templating syntax here for the component. And this is just basically Angular code here. As you can see here, we have a list of months, list of years, and then depending on the month, we sort of set the days per month. We have some event handlers, what happens when we delete or create a new document or insert or update. And the rest are pretty much functions that validate the document's name, the year, the month, and so on. So nothing too extraordinary there. So as you can see, the components are structured under each folder, one for DE base, and which is the main screen, and another one for DE form, which is a secondary screen. So if we look at our model, we can see that we have some utility functions. For example, this is very useful when we create a new document because we want to generate a unique random string. So each document has a unique identifier internally that we store in Firebase. And each document obviously has a set of properties, right? So it will have an ID, it will have a document, a year, a month, a day, expiration date, status, batch, and so on. We also determine the status of the document, which is what we can see here. So this would be the status, right? So expired or the amount of days. So depending on the amount of days, we will give it a different kind of batch, which with a different color. So for example, if it's expired, it will show in black or dark. If it's less than 30 days, it will show in this danger, which is sort of red. Warning would be sort of yellow, and this goes like to blue, darker blue, lighter blue, and then eventually you end up with green, which is the when it's more than 365 days. So this is just a nice way to give the user a visual representation of how urgent the document should be renewed or not. And we also have in the model a couple of functions. One is how do you update the document itself and its data in memory before it gets submitted to Firebase. And we also have some sorting functions. So obviously this list here is sorted by expiration date. So that functionality is described here in the model by using the sort documents function and this handle sort order function here. We also have functions to transform the data in Firebase into a memory object that the application can consume. We do that from here, and also the other way around. So how do we store the information from the app into Firebase, and how do we transform that object so we can do that using this other function? So if we look at the service, this is basically responsible for talking to Firebase. So it basically, we define our Firebase API here. We say which is our Firebase applications URL, where the database is stored. And obviously we have a project ID and a bucket where that JSON information is stored. So we define these parameters here, and we say that our database in Firebase is going to be called docs. We initialize that, and then this function is responsible for issuing a query to Firebase and retrieving all the values stored there, and then we basically return a list of documents. So we use the model, as you can see here, and by using the from map function, the record that we receive from Firebase is transformed into an object that the application can display, which is this one, like these here, which is, as I said, defined in the model that we just saw. So here, right, so that would be the from map function, and we basically call that to be able to render the data from Firebase as an object that the application can understand. And we also have some Firebase related functions, like how to add a document. So if we create a new document, this add doc function will be called, and that JSON object will be pushed into Firebase. The same if we want to update or if we want to remove a document. So it's essentially using the Firebase API that we defined here in index.html. So it's going to be using this API here, and that's essentially what the service does. And that's pretty much it. So there's really nothing more to this application. If you come from a background of Angular and TypeScript, this will look very familiar. If you have used Firebase before, this should also look very familiar. And the structure of the application is also quite standard, I would say. You have your specifications file, your main entry points, and then your main component, right? And that main component references another component, which is this one here, and that component is structured into a folder with two files, a Dart file and an HTML file. And that component then references a secondary component, which is Deform, which is also structured in its own folder. And then you have a folder for the model and one for the services. If your application would have more components, then you would have more folders and structure that way. So it's a nice way to keep the application logic structured and organized. So that's it really. As you can also see, that wasn't too much code. And again, for someone coming from an Angular background, I think picking up Angular Dart is quite straightforward. The only drawback that I found while creating the application or writing the book was that there's not a lot of documentation on the web. So it's actually also one of the reasons why it was a good topic for a book, because there was really not much written about this technology, as it's been traditionally used internally in Google. So it's still a great technology. It's really forces you to structure your code in an organized way. Basically separation of concerns, so components on one side, models on another side, and then the logic that communicates with the database as a service. So it really forces you to think that way. And again, I think it's a great framework, and it builds on the years of experience that the Google team has been working on Angular. So yeah, I hope you get excited about the book and read it, and it could be of great use to you as well.
All right. Thank you again for joining us today, Ed. Do you have any other points you'd like to add?
No, I think that's pretty much it. Again, I think the main thing here for people to remember is that this is Angular, so this is not some other language. This is actually Angular with a flavor of Dart, and it's exactly the same Angular that people are used to using with TypeScript. So it's the same framework. So it's what gives, well, um, I would say the value of actually using this technology is because it's Angular. And Dart is also a great programming language. If you come from a C language background, it's very easy to pick up. You can see that the syntax is basically very similar um, to C Sharp and Java. So it's really easy to pick up for anyone coming from a C language background.
All right. Well, thanks for watching, everyone, and we'll see you next time.
Thank you so much.